All right, welcome back from spring break. We're going to start graphing the trigonometric functions. We're going to start off by graphing all 6 basic trigonometric functions. You are going to be required to label certain points. You'll need at least 5 points in each graph within one cycle of the graph. This first one, the basic sine function, I have drawn on the board the unit circle. I'm going to draw it on here just because if you're looking at this video, then you can't see the unit circle that's on the board. Okay. Don't know why my circle isn't all that great, but oh well. Let's think about the quadrantals, please. If we were at 0 degrees, what's the point right there? 1, 0, okay, on the unit circle. Up here at pi over 2, that point is 0. I don't want it to look like I'm writing anything, but that'd be 0, 1. Over here would be negative 1, 0, and that's pi. And then down here at 3 pi over 2, the location is 0, negative 1. Those are going to be key values that we're going to need to know. And we're supposed to remember that our points were written cosine, comma, sine. And that cosine with exact sine is y. All right, so if we want to graph the sine of x, you made a little t-chart. X, I'm going to call x theta, if you will, for a moment. And then here would be your sine of x or your sine of theta. I don't want you to confuse it on your unit circle with the x and y's that I'm talking about. That's why I'm writing a theta right now. Theta is simply a Greek letter that's used for an angle measure. Okay. What is the, remember sine's the second number in the points. What is the sine at 0? It's 0. It's the second number in the ordered pair. So when you're graphing, the sine wave starts at 0, 0. When you get up in the first quadrant, the sine is staying positive. All the sine values are positive in this quadrant. And then you hit pi over 2. And the sine is there, not 0, but the second number is 1 in the ordered pair. At pi over 2, you're at 1. Now, there were some things in between that I thought I'd just mention for a moment. Between 0 and pi over 2, halfway, would have been pi over 4. Do you remember what value is at pi over 4 for the sine and the cosine? Okay, at pi over 4, you had square root of 2 over 2, square root of 2 over 2. Well, if you type that on your calculator just to see what that is as a decimal. Ooh, I've got some stuff in here from last hour. Get rid of that stuff. If you typed in square root of 2 divided by square root of 2, oops, I forgot to put the 2 in there. That would be helpful. Get out of there and then hit divide by 2. That is about 0.707. Well, look, if you're a pi over 4, 0.7, that's 0.56. That'd be right around there. So what's actually happening is this part of the graph is coming up, and then it's getting here, and it's going to come back down. When is it going to reach 0 again? Well, let's go back to our quadrantals here. It's going to come back down to that 0.7 again, right about here at 3 pi over 4. It should be in this quadrant there. And I'm going to kind of skip those now from then on. I'm going to go to the ones that I want labeled. All right, so when we hit pi, we're back at 0. Because at pi, the cosine, or the sine, excuse me, is 0. It's the y part. And then we get to 3 pi over 2, we're at sine value of negative 1. And then when we get back to 2 pi, we're at the sine value of 0 again. All right, here are our key points. We got the top maximum point at pi over 2, 1. We came back to the x-axis and hit pi 0. Bless you. At 3 pi over 2, we get down to -1, so let's just get that one in there. And then at 2 pi, we're going to hit back to 0. Now, what I want you to think about is that that is one cycle. It would start to repeat after this point. So, knowing that the period for the sine wave is 2 pi, it is a cyclical wave, the hump would start back over and you'd go back up to 1 if you were to extend it. You don't need to keep going, but that's what would happen if you wanted to keep going. All right, so what we need to have is 5 key points. We need the 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1 labeled, and the last one, 2 pi 0, that you are required to label. And that's the first graphing of the sine wave. So cosine is going to be similar, but a little bit different. Can we go over to cosine now? Okay, we're going to graph the cosine. The period, what do you think it's going to be? Sine and cosine, very, very similar. It's going to be the same period. It's going to take 2 pi units to go around the unit circle, okay? And it's going to change over that period. Now, get back there looking at your unit circle. Again, if you're looking at your quadrantals, thinking of these points, this would be 1, 0. So the cosine's not 0 here, it's 1. So if this was your angle theta and this was cosine theta, or x, so again, not trying to confuse you that the cosine is the x value here and the y value of the point. What we're graphing is just the radian measures versus the value that would count in that point on your unit circle. So 0, oh no, at 0 degrees, we're at 1 for the cosine of 0. Cosine of 0 is 1. At pi over 2, the cosine is 0. At pi, the cosine is -1. Again, that's the point I'm looking at right now. Okay. At pi over 2, my pen just got stuck. This was 0, 1. And here it's at 0, -1. Okay, and then last, I got 3 pi over 2. The cosine is 0, and at 2 pi, the cosine is back to 1. All right, so let's get that graphed. 0, 1 would be the first point. Now I'm going to go ahead and plot them and sketch the curves, and I'll go ahead and label them so we don't make a mess. So I got pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, 1. Sketch your curve. Make sure it's curvy, not pointy. These are like quarters of circles, even though it can't look like that because this is actually not scale. If you think about it, pi is 3.14 and 1 is here. So this is really stretched on the vertical axis. It's not realistic looking. Okay, I'm going to label the points now, 0, 1. This would be pi over 2, 0, pi -1, 3 pi over 2, 0. What happened to my line there? And the last one was at 2 pi, 1. Okay, 5 key points must be labeled. There's your cosine wave. Now, if you want, I'll show you in the grapher how you, of course, can type these in and remind you what you have to do if you want to look at a graph in the calculator. If you put sine x, you'll need to go to zoom and then choice 7, trig. Once I got it in that mode, it'll graph everything in that mode. Till I change it. All right, so what we graphed was from here, guys, See here, it's not going to tell you the values. We did sine wave from here to here. It's showing you a lot more than one cycle of the sine wave. If you wanted to go backwards, which we will have to do, you're going to go back and make the wave going that way, and you'll need to be able to label the axes. It won't show you, and you cannot use what's in the table because it's in decimals. Okay, you have to have the exact labels. If you wanted to look at cosine, looks kind of pretty putting them together on a color grapher because we push cosine x. And now you can see that it did start here at 0, 1, and then come down, etc. Right, and one cycle is just what we just got through graphing. All right, now we're going to graph the tangent. I want you to think about your unit circle again when graphing this. Okay, so I'm going to make another little t-chart. And if I call that theta and tan theta instead of x, what's the tangent at 0? Well, if you're back at your unit circle, I'll remind you of those points again. This would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. The tangent at 0 is y over x, so it's 0 over 1, which is 0. Don't write the 0 over 1. If you write 0 over 1, at least simplify it for me. That would be 0. We know that's the point on the graph. Now we're going to go up to pi over 2. That's y over x. Well, that'd be 1 over 0, which I can't do. So that's we call undefined. Now, that tells me this graph has an asymptote. If it's undefined there, then I can't plot anything on that. It's going to be an asymptote. Wherever the tangent is undefined is an asymptote. So it says calculate points and determine the vertical asymptotes over the interval negative pi over 2 to positive pi over 2. This is an asymptote we just found. Okay, now let's continue. Let's think though, what happened in between here if there's supposed to be a graph in there? So what would be halfway between 0 and pi over 2? Pi over 4. Okay. And if you remember, that point is square root of 2 over 2, square root of 2 over 2. So let's just figure out what pi over 4 was. That'd be y over x. So you'd have square root of 2 over 2 over the square root of 2 over 2, which is same thing over the same thing as always, 1. So actually, at pi over 4, and you don't have to have this label, but I'm going to show you that the graph was going up from 0, 0. And then it's going to run along its asymptote. So let's figure out what was happening going this way. If we were at negative pi over 4, it would be over in here. And at negative pi over 2, which would be down here, wait a minute, that's going to be y over x, so that's negative 1 over 0, so it's also undefined here. See what I'm saying? Look, guys, y over x, undefined then at negative pi over 2. So I've got another asymptote there. All right, then, well here, if this is positive square root of 2, negative square root of 2 over 2 for the location of negative pi over 4, that's going to be negative 1. So that just showed me for sure that I need to take my graph and go down with it and run along that asymptote. Where do you think the next asymptote is? Okay, you see there's one at 1 pi over 2? It's going to happen again here. I got to fit a whole twist in here. If I wanted to come and show it, I'd need to have another asymptote coming up at 3 pi over 2. And notice again, 3 pi over 2, guys, is down here. That is undefined there, negative 1 over 0. So this is what the tangent looks like. That means if I wanted to go back further, and I know some of you looked in your graph for see what was happening. You see how we could draw a bunch of these like this? Are you taking notes? Okay, I'm going to go in here. Let's go show you how to type this in. Well, you know what to do. Just hit tan X. But again, you've got to know where those asymptotes are located. Okay? They're located at every pi over 2. Or pi unit, excuse me. Okay, let's look at secant and then cosecant. First thing I want you to think when you try to graph a secant or a cosecant is, what is its reciprocal function? What is the reciprocal of the secant? Okay, so the reciprocal is y or y equals cosine x. So I'm going to use a cosine wave to help us graph it. So if you memorize your cosine graph, you can get the secant graph from it. Cosine starts at 1. I'm going to sketch a very light, you can do this lightly if you're just having pencil, or you can dash it. It goes 1, 0, negative 1, 0, 1 when it ends at 2 pi. You're going to want to get this one memorized really fast. So it's up, down, right, up, 0, down, 0, up. Something like that. One way to think of it. No longer am I putting in, making a chart. I'm just not doing it. What's the reciprocal of 0? Okay, 0 over 1, if flipped over, would be 1 over 0. Can you do that? So that means wherever this thing hits 0, the secant is not defined there. That means the secant's got to have asymptotes. Okay? Because the cosine graph does have values at 0 on this graph, the secant will not. It will have asymptotes at those points. So I'm going to put in some little dashed vertical lines in here. What does it mean to you, and you can't see me if you're just listening, but when you have a reciprocal, what did I always tell you to do? Or your teachers always said to do the I say reciprocal, right? You flip over the fractions to do a reciprocal. Well, if a reciprocal is flipping over, then I'm going to flip this graph over. So since the cosine graph goes from 1 high down to 0 low, I'm going to reverse that. I'm going to go from here, because that would still be 1, and go up. And run along the asymptote. Now this one, little smiley down here, we're going to turn that smile upside down, and it's going to go, instead of from there, it's to start there and go down, flop it over. And then in this piece, it went from 0 up to 1, and we're going to have to start at 1 and go up to infinity. That is your secant graph. I'm going to show you something on the calculator quick again. I just told you that secant was the reciprocal of the cosine. Cosine x, I had you graph. Look like that. And then I told you, well, let's do the reciprocal. How could I type the reciprocal of cosine x on line 2? Let's cosine x over 1. I'm going to flip it over. 1 over cosine x. 1 divided by cosine x. This is the way you can actually graph secant in your calculator. What's kind of neat to see is that that's exactly what we did, and that's why I had you graph the cosine lightly so you could see it flip over. All right. So now with that in mind, what do you think we should graph for a guideline for the cosecant? It's the reciprocal of, I don't know why I have 2 C's in the word reciprocal. This is the reciprocal of the sine of x. Okay, so I'm going to graph a little sine wave. Sine starts at 0, 0. At pi over 2, hits at 1. At pi, 0. At 3 pi over 2, negative 1. And at 2 pi, it's back to 0. Now I can tell where my asymptotes are for this graph. They're not in the same place as the last graph because the sine is 0 in different places than the cosine is. So wherever the sine is 0, the cosecant is going to be undefined. So I've got an asymptote right here at the y-axis. And then my next one's at pi. And then my next one's at 2 pi. Okay, so if I have a hump here going upside down, I'm going to reverse it. This point will remain the same at pi over 2. That is not, the value of 1 would be the reciprocal of itself, 1. So it opens up along its asymptotes. And over here, it turns down. Am I going too slow or too fast? Or are we okay? Anybody having trouble keeping up? Oh, this is making some sense. This is how you remember it. Okay. You also can type it in the calculator, but you're going to need to know, though, where the asymptotes are, be able to tell where the asymptotes are. And by the way, this has a period of 2 pi, just like the reciprocal function, the sine. The period is 2 pi for the cosecant and the secant. All right, so what's the one we haven't graphed yet would be cotangent. And again, if you wanted to go and type this into your grapher, you would type 1 divided by the sine. I've seen some of you playing around with your graphers and getting all kinds of designs and stuff before once you got into these things, yeah. Oh my. What's missing? What's not here? This is only the cosecant. I didn't graph the sine wave this time, but you could think about the sine waves right there. That's what we used it as a guideline. All right, last one of these cotangents. We've seen all of the basic trig functions graphs. If the cotangent is the reciprocal of the tangent, then wherever the tangent was undefined, the cosine won't be, and wherever the tangent was defined, the cotangent 0, or where tangent was 0, the cotangent will be undefined. So the tangent had an asymptote right here and here. So that's going to move over. The cotangent's going to have its asymptotes. And I'll explain that. I can't really say it another way. Remember this point on the unit circle. Put these on there again. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. The cotangent is x over y. Tangent was y over x. So x over y, the cotangent's undefined at 0. 1 divided by 0 is undefined. So there's an asymptote here. And then there's going to be an asymptote at pi, because x over y, again, would be undefined there. And the tangent did a twist that went like that. So what do you think happens to the twist? It's going to flip the opposite way. So instead of down, up, it's going to go up, down. Meaning the twist will happen in this section. It's going to hit 0 at pi over 2. It should look something like that. Now that's one whole cycle. That means the period of the cotangent and the tangent is not 2 pi. It's just pi units. If you wanted to extend this graph, you'd put another asymptote every pi units or back pi units. My pen got stuck. And then you could make some more twists. Okay? And the only way to type that one in the calculator is to type 1 divided by the tangent. Actually, not the only way. What is another way of saying the inverse? Well, I just showed you we have it graphed correctly. You remember that inverse tangent button? Let's see if it makes the same graph. I don't know what happened. I don't think that works, does it? Oh, I guess I wonder if I have to do... No. That didn't work. There's the tangent. 1 divided by the tan. Oh. So you can't use that key. You have to type 1 divided by the tangent. The only way you can type it. I don't think that that's what that means. All right, that was it for that page. Now I want you to go to your 22. And just talk a little bit about what you see on that paper. Now, I couldn't find that page in one of my little pictures. Do you see the one that says amplitude? What's changing on the graph? Yeah, it's stretching which way? Up and down, right? Isn't it stretching vertically then? Okay, that is a vertical stretch. That's all you could write on there. You don't really need to say anything else except if you multiply your sine or cosine, it can be that A value will stretch it vertically. Okay, that's all it does. So instead of going up to 1, it will go higher than 1, or if it's lower, if the A value is a fraction, it's going to shrink between 0 and 1. All right, what I would like to do then, go flip that page over so I'm side B. I want to look at the change in periods. We're going to go really fast through these pictures. All I want you to be doing is seeing what's going on with the cycle. Y equals sine x has a period of 2 pi. Sorry, I'm starting on the right side of the paper. We'll get to the cosine second. Y equals 2 sine x. This is its graph. I want you to take note of what happened. There's your 2 pi. How many cycles have occurred? 2. So that means the period is now pi. So period is pi for this particular graph. The next one. Now the cycle is happening 3 times in the period of 2 pi. So that means that the period is 2 pi over 3 units. Whole cycle occurred in 2 pi over 3. One 2 pi over 3, another 2 pi over 3, another 2 pi over 3. So you got 3 sine waves in there. The next one says sine 4x. What's the period now? Doesn't show it. It's right here. 1. Another one, 2, 3, 4. So what happened to the 2 pi period? It went and got divided into 4, which is pi over 2. Okay, so what we're going to surmise here, I want you to notice, you don't have this one, do you? All right, so you take if it's in this form, y equals sine bx. The new period is 2 pi divided by the b value. It just, for this particular one, the period would change to 2 pi divided by 5 or 2 pi over 5. So it squishes the graph. That multiplier being in the parentheses here, you got to know this, changes the period of the graph. It makes it happen either faster or shorter. If these were fractions, it would stretch the graph horizontally. Okay, so this is a horizontal shrink or expansion. All right, cosine x, same idea. The period here equals 2 pi. Cosine 2x, 2 pi divided by 2. The new period should be pi units, and that's exactly what we see here. I'm going fast now on this. This one would have a period of 2 pi over 3. And this last one would have 2 pi divided by 4, or a period of pi over 2. And that's how you find it. That's how this one's cut up. Okay, so let's graph a couple. So now I want you to go to worksheet 23. Let's do a couple graphs. So here you're going to be given some arrows, and this is as basic as I can make it for you to start off how you're going to graph. And this is where some students like to have a ruler, because you're supposed to keep within your range vertically and So I'll show you what I'm talking about. This has an amplitude. This is in the form y equals a sine x. A is the amplitude, and it just stretches it vertically. So it's stretched vertically by 2 times. Well, where did the original sine wave max out? What was that? Highest point was 1. So we're going to have to go up to 2. And then it went down to -1, so we're going to have to go down to -2. And this is still 0 where my center line is. All right, now I know I'm going to graph. It says from 0 to 2 pi, which the period for this one is 2 pi because it's a sine wave. Period equals 2 pi. It says go from 0 to 2 pi, so that means we're going to graph one cycle. So I'm going to make my 2 pi way out here on my x-axis. And then I'm going to cut this in half. And I'm just eyeballing it. I hope we can try to do a fairly decent job with eyeballing it. I would like you to not have this be like way over here if it's middle. Okay. Now, we need 5 key points. Right now, we only have a spot for 1, 2, 3. So what we do is we cut these in half. Okay, and half of pi would be pi over 2. And then I'm going to cut the pi to 2 pi section in half and label it 1 pi over 2, 2 pi over 2, 3 pi over 2. And now I'm just going to graph my sine wave. So the best thing to do is start memorizing that sine starts at 0, 0, goes up to its max, so it's going to happen at pi over 2. And here's what I meant by staying in there. Some of you might like to put in little dashed lines if you want to hold you horizontally within the 2 units there. And down here, 2 units. I know some students are more picky or fussy about their graphing than others. I'm not going to go crazy with you, but one thing I won't tolerate is pointy graphs. These are not pointy. They're not V's. So it's going to be a curve from 0 to 2. And it's going to be a curve when it comes back down to pi. And mine's not perfectly separated, but it's not bad. Okay, and then you're going to curve down and back up. So I got my key points. Now I got to label these points. Okay, so the first one, 0, 0. Second one is pi over 2, 2. The third one is pi 0. The fourth is 3 pi over 2, -2. And the last one is 2 pi 0. Okay? Practice a cosine again. Amplitude of 1/2, that's going to shrink it by 1/2. So instead of coming up to 1, we're only going to go to half of that. So I'm just going to show it on my graph, not doing anything dramatic. All I need is to see that you know what it did. If you want to put those little horizontal dashy lines in there, you can. They're not really there at all. It's just a guideline. Bless you. Bless you again. All right, the period here is 2 pi because there's no number in front of x. So let's just mark something out here, 2 pi, and then start chopping it in half. And labeling that pi, then half of that, pi over 2. And the halfway from pi to 2 pi, 3 pi over 2. You need to get used to doing this labeling. Okay, okay, now cosine started out a pi at 1. So instead of starting at 1, it's going to start at 1/2. So 0, 1/2 is our first point. Then it comes back to pi over 2, down to -1/2, The last step will be for us to label these. 0, 1/2 is the first one. Pi over 2, 0 is the second. Pi negative 1/2. 3 pi over 2, 0. And the last one, 2 pi 1/2. I did plan on doing another graph. You might want to start practicing some on 24 and 25, the ones that we've talked about. Okay, so these are just amplitude changes. I'm just going to skip that. I want to do one with the period change so that you can start doing some graphing if you like, get a little ahead. We'll be graphing for a few days. At the end of the week, we're going to have our unit circle test where you have to know how to fill in that whole unit circle. So I'm going to have some blank ones for you tomorrow. Maybe I'll give you a couple of, I'm going to have a blank one on the front, blank one on the back, you know, so you can practice filling that thing in, all right? And this exercise today should have helped with learning how to graph them. What's the period change on this one? I just want to quick graph this one. See, that's a B. All right, the new period is the old period, 2 pi divided by the new B. That gets you the new period. So this one's going to be 2 pi divided by 2, which is pi. All right, so we'll still have 0. Our amplitude is still 1. We're going to go up to 1, down to negative 1. We're only going to go out to pi units. Oh, it said to do it to 2 pi. So let's cut that in half, and we'll show that one cycle is going to go from pi units. So ignore this end mark for a moment. We're going to graph a whole cycle right between 0 and pi. So we're going to have pi over 2 in the middle. What's half of pi over 2? Pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4 would be the next one. Now let's just graph one cycle here quick of the sign. We'd be way up here. Oh no, excuse me. I just did a boo-boo. Sign starts 0, 0. Pi over 4, it's going to get up to its max. So that's going to be pi over 4, 1. Then I'll be back to pi over 2, 0. 3 pi over 4, negative 1. My pen's stuck. And then back to 0 at pi. So pi 0, and then you would need to extend that on, but you don't have to label every point after that. You just cut this up and then keep your little pattern going to extend it out to 2 pi units. All right, might start practicing some graphs. Make sure you're caught up and ready for questions, though, also on page 851. We'll do a little SAT practice and maybe some questions tomorrow on old stuff. There will be a quiz through a lot of stuff on Friday, but not graphing.